Hi and welcome to the next lecture. Okay, so this is a big one, probably one of the more difficult ones I've put together, just in terms of how to explain this to you and present it. But I think I've come up with a good way of doing it. So these are the things we're going to cover in this lecture. So basically, PBR, what does it mean? This term PBR has been battled around all over the place, so we're just going to clarify exactly what that means. And then we're going to talk about why it's been so confusing. That there's a lot of confusion surrounding PBR and what it is, what the terminology is, and everything. So I'm going to explain why it's confusing, and then we're going to look how it works in Unity. And I've chose that specifically because PBR is not different. The fundamental system of how it works is the same throughout, but different packages use different terminology, different maps, different things, and various differences between each one. So I'm going to focus on Unity and one PBR workflow within Unity, just so you can grasp that. Once you've grasped that, it'll be a lot easier to branch out and look at the other ways of doing it. So, and then we're going to talk about the benefits of using this system as opposed to the previous system rendering engines used to use. Then we're going to talk about how to author the PBR maps, and of course for this we're going to use Substance, but there's other ways you could do it. And then I'm going to give you some additional reading for a more in-depth look at how it works, because I'm not going to go into the technical details of how it actually works, just how it works from an artist's perspective. So let's move on. Let's get started. So PBR, what does it mean? It means physically based rendering. That's it, PBR, physically based rendering. What that actually means is PBR is a realistic shading lighting model and provides an accurate representation of how light interacts with surfaces. It mimics the real world. It takes values from the real world and uses them to render surfaces. So PBR, physically based rendering, really is all about how light hits a surface. That's essentially the crux of it. And in the real world, light hits the surface in lots of different ways. If it's metallic, it can bounce off, and if it's dielectric, it can absorb and bounce around inside the material before it comes out, or not come out at all. If it's charcoal, which is the darkest material on Earth, the light is just absorbed, and there's no reflection, no bounce on the light at all. So that's what physical based rendering is. It mimics real world materials. And there you go. PBR simulates how light interacts with real world materials. It is the new standard in video game rendering engines. The previous system we had to create diffuse maps, specular maps, and obviously normal maps are still the same, but we would have to modify those diffuse maps to work differently in different lighting environments. But with PBR, no matter, once you've set up a material, if you set up gold, for example, gold is always gold in PBR, no matter what lighting, and it'll render correctly no matter what lighting model is used. That's the beauty of PBR. It's you set it up once and it's done. You don't have to keep changing it. You can do if you want to, but it's it'll be true to how it is in the real world. PBR is not new. It's I believe was invented by Disney around 20 years ago, and they have been using it offline since then to render their movies. And that's why they look so damn good. And it's only now that technology in games have got fast enough and clever enough, if you like, to be able to use this technology. So it's a big shift in game rendering. quite substantially, I'd say. I mean, if you've played Uncharted 4, for example, on PS4, you'll see what I'm talking about. The rendering, the graphics, the worlds that you travel through in that are just phenomenally awesome looking. And that's just the start. So you can imagine what it's going to be like in the future with faster, bigger memory, more graphic capability and power. We're just going to take this technique and just use it with no bounds. It's going to be fantastic. So, why is PBR so confusing to people? And it is confusing. When I was putting this lecture together, I was online, I was doing research, and the amount of confusion and contradiction is phenomenal. It's just so much out there. People arguing about what is and what isn't, and this is why I've chosen this path, is to keep it narrow so that you can get a good grasp of at least one channel of PBR and get it working in a really good way, and then you can sort of step back and go, okay, I understand that, and now I'm going to branch out and have a look, well, what was this he was talking about, and what was that, so you can explore different avenues once you understand one, and those avenues will be a lot clearer to you with a good understanding of at least one path. So, like I say, naming conventions, inconsistent, and it often is confused with an older model, because people use the word diffuse, and they say, oh, that's the diffuse and it should be the albedo, and it's not diffuse, it's albedo, and there's a very fundamental difference between the two maps, and we'll cover that when we get to the albedo section. But the terminology is one thing which needs to be cleaned up, really. I'm not quite sure how to do that or how people should do it, but if you learn how it works in Unity, then you'll have a good understanding going forwards. Yes, and setting up PBR in different engines is not the same. So the way I'm going to show you to do it in Unity is not the same as you do it in Unreal, for example. It just isn't, and they've also got different names. Unreal and Unity use different naming conventions, although the underlying technology is the same, and the methods they're using to render the materials, the shaders are the same ideas. It's just the way the user inputs the data is different, and that's what makes it quite confusing. And this is another thing. Unity has two PBR workflows, a standard specular and a standard metallic. And we're going to be using the standard metallic. We're not going to be using standard specular. There's a very subtle difference between the two, but like I said, we'll use standard metallic, and then perhaps as an update I'll cover standard specular as well. But let's just focus on one, get one done, get one understood, and get one working really well in your mind, and then that will just pop. You'll understand what standard specular is once you understand standard metallic. Standard metallic is a lot more efficient as well in terms of the maps it uses. I'm right in saying it's the preferred method within Unity. So you can see why all this is confusing. It's not good for new artists to come into this kind of environment where everything is named so different. So I would, recommend that you just stick to standard metallic in Unity, like I'm going to show you. This will give you much more clarity. So just as a little note at the bottom to explain what a shader is, it's basically a piece of code that calculates the data required to render the appearance of a given surface. And what we have to do, that shader just sits there and it waits for you to feed it information in the form of colors or bitmaps or texture maps, and then it calculates the information you've given it and renders the results or outputs the visual result onto the screen. So that's what a shader is basically. It's like a hungry beast just waiting to be fed images and textures. So in this context at least. So that's a lot to get through. So I'm going to start a new lecture now, and we're going to start looking at the way Unity puts it together. So I'll see you there.